Hello everyone, today we're going to talk about convex sets. What is the definition? And in other videos, I'll give you exercises that we will correct together. And yeah, so what is a convex set? A convex set is just something where, uh, let's say that we have S being a set, it is included into V, which is a vector space. That having a being into a vector space, then we say that S is convex if for all x and y being into the sets, we have lambda x plus 1 minus, and yeah, and lambda being into 0 1. So that's the two condition on x and y and then lambda x plus 1 minus lambda y is being into S. So, for example, if you can to think to a convex set, intervals are convex sets because so let's say like for example 0 1. If you take 1/2 of something between 0 1 plus 1/2 of something between 0 1, it will be into 0 1. No matter what your take, like it will still be into 0 1, like all combination of lambda that you choose, and x and y being into the sets, so x and y being into 0 1 in this case, and lambda is into 0 1 by definition. And so if you try to apply this definition, you will see that you cannot find some x and y such that you do not go, that you can't go outside of it. So that's it for it. Maybe I don't know if I think it's clear, but maybe yeah. So other type of convex sets can be balls, hyperplanes, half space, probability simplex, positive semi-definite matrices. But in general, if you want a more visualization things, it just means that 2 points are 2 points x and y are into well, I think it will be clearer if you do it like this. So up. So that's convex sets because like the line, you have a line segment between x and y, which is still inside the sets. you know. Here we have, in a way, this line can represent lambda x plus 1 minus lambda y. And so you know that's the definition, and it's still into the sets because that's the sets. And so here we still have the line inside the sets. Um, and when it's not a convex set, it's just that the line is not uh, inside the convex set. So that's convex set here because the line is inside. And here, for example, that will not be a convex set because I'll show you. So we have x and y, but this time, if it's not convex, you'll not have something englobing both. But for example, like so, you have your line, which is one another time lambda x plus 1 minus lambda y. So for example, it can be like this. And so you see y is not into the set. Lambda x plus 1 minus lambda y does not be into the set, and so it's not a convex set. So that's the definition of convex and not convex sets, and we'll see after definition of convex functions. But I think in the next video first I will just give you an example of demonstration, like if S1 and S2 are convex sets, and it is equivalent to say that S1 inter S2 is a convex set.